Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about writing linear equations from graphs. And the word linear should bring up the idea that we are going to be increasing or decreasing at a constant rate. So the word linear means increase or decrease at a constant rate of change. When we're writing equations of lines, linear lines, we're going to be looking at straight lines, which means they are increasing or decreasing at a constant rate. So the straightness means that they're linear. Those kinds of equations are going to have two variables, an independent and dependent variable. They're going to have a starting point, and they're going to have a constant rate of change. Now, in this example, I went ahead and made a kind of a mock example here. Let's say I had the equation h equals 5 plus 18c. And let's say we knew that c represents the number of seconds, and h is the height of a rocket off the ground in feet. So here, our starting point would be 5. We would say 5 is the starting point. That's how high off the ground it starts before it took off. 18 is my rate of change. It's constant, so I'm constantly going up 18 feet every second, or 18 feet per second. And then c would be my independent variable. Independent because I'm going to be plugging in values for c so that I output a value for h. So h, whatever the value comes out for h, is completely dependent on whatever I make c. So for example, if I make c equal to 1 second, then I would take 1 times 18, which is 18, plus 5, which is 23, so that h would equal 23 feet off the ground at 1 second. And so we can see how h is completely dependent on c. Now, here's a graph that you may be given, and your task is to write the equation of the line. I already went ahead and wrote the equation of this line. It's f equals 15t plus 0. But let's give some context here of what this means. So we have two variables, f and t. And let's go ahead and say that f is the number of feet off the ground for the rocket, and t is the time in seconds. And so here we can see that the starting point of the rocket was 0 feet off the ground. It started at 0 feet off the ground, so that's why we have a plus 0 here. That's its starting point, 0. And then the 15 rate of change comes from the fact that we know that every two seconds this rocket was increasing 30 feet. So every 2 seconds, the rocket was increasing 30 feet. 2 seconds, up 30 feet. 2 seconds, up 30 feet. And we can continue on like that. And we could say 30 feet every 2 seconds is the same, reduced to 15 feet every 1 second. Okay, so that's where we get the 15 seconds from, or 15 feet per second from. And then if we looked at it maybe in a little different light, that rate of change, we could say that would be the same as saying, well, you know, if I went over 4 seconds and I went up 60 feet, that's the same rate. So you get 60 feet every 4 seconds. That will reduce again to 15 feet every second. Okay? Now here, t, the time, is our independent variable. We're going to be plugging in values for t. And f is going to be our dependent variable, because it's completely dependent on how much time has passed. Is going to be how high off the ground the rocket is. So our equation would be f equals 15t plus 0. And you don't necessarily need the plus 0 there. If you would like to write it, you can. You don't have to. Let's look at another example here with this graph. Let's suppose then we were told that h and d are two variables, and we have the meaning of these variables. H is the height of a mountain climber off the ground in feet, and d is the number of days since he started traveling down the mountain. And so in this case, we know that he started his travel down the mountain. He was 1,000 feet off the ground when he started that descent. And we also know that from the graph, from the rate of change here, every 100 feet that he goes down the mountain is taking him 3 days. Every 100 feet down the mountain is taking him 3. So 100 feet, 3 days. 100 feet, 3 days. Okay? And so if we were to make that a unit rate, we would take 100 divided by 3, which would be 33.3 repeating. So each day he's traveling down the mountain 33.3 repeating feet per day. So the equation we could write for ourselves is 1,000 minus 33.3 repeating times d. And d here, the number of days, is our independent variable, and h is our dependent variable. So the height off the ground is completely dependent on the number of days that he's been traveling down the mountain. So for your homework tonight, I'd like you to take a look at two problems. And what your task is to write the equation of the graph in context of what we know. So here, number one, let's say we know that P and Y are the following variables. So P is the price for a stock. We don't know what company. And then Y is the number of years since 1990. And then, so write the equation of the line. And number two, we have W and M being our variables. So let's go ahead and say that W is the baby's weight in pounds, and M is the number of months since the baby's birth. So we're writing an equation for how much this baby weighs after a certain number of months after it's been born. So have this ready for Tuesday, and I will see you all in class. Thank you very much.